For generations, humanity has looked to the stars, not just for wonder, but for answers. Is there life beyond Earth? Are we truly alone in this vast cosmic tapestry? Among the celestial bodies, Mars, our crimson neighbor, has always held a special allure. Its stark, desolate landscape whispers of a past when water flowed freely, when an atmosphere might have cradled life. But what if that life wasn't just microbial? What if, before the first human walked the Earth, before our earliest ancestors even dreamed of civilization, Mars was home to an advanced society, a civilization that rose, flourished, and ultimately vanished, leaving behind only enigmatic echoes across the void of space and time? This isn't science fiction, it's a profound thought experiment, an exploration of the tantalizing possibility that our cosmic origins might be far more complex, far more ancient than we ever dared to imagine. What if Earth is not the cradle of our civilization, but merely its latest chapter, a legacy inherited from a world that once thrived millions of years ago on the red planet? To truly delve into the premise of a Martian civilization preceding Earth's, we must first confront the planet's own deep history. Modern science paints a picture of early Mars as a far cry from the barren world we know today. Billions of years ago, it was a warmer, wetter planet with a thick atmosphere, vast oceans, and flowing rivers, conditions that, for a significant period, were potentially more hospitable to the emergence of life than early Earth. This habitable window on Mars is estimated to have closed around 3.7 to 3.5 billion years ago, long before complex life took hold on our own planet. The question then becomes, if life did emerge, could it have evolved beyond simple forms? Could it have progressed to intelligence, to tool-making, to the very foundations of civilization within that ancient, verdant Martian epoch? The sheer scale of cosmic time suggests that anything is possible. The 200 million years between the emergence of complex multicellular life on Earth and the Cambrian explosion, for instance, saw an incredible diversification. Could Mars have had its own Cambrian explosion of intelligence, a flourishing of advanced beings before its inevitable decline? If a Martian civilization did exist, what traces might it have left behind? Unlike Earth, Mars lacks plate tectonics, a process that constantly recycles our planet's surface, erasing ancient history. This means that if structures or artifacts were built on Mars, they might still be there, albeit buried under eons of dust and regolith, or eroded by solar winds and micrometeorite impacts. The famous face on Mars in the Cydonia region, though largely dismissed as pareidolia by NASA, continues to fuel speculation. What if it and other geometric anomalies observed on the Martian surface are not natural formations, but the weathered ruins of ancient cities, monuments, or even industrial complexes? Consider the possibility of subterranean cities built to escape the harsh surface conditions as Mars began to lose its atmosphere. These could remain largely intact, waiting to be discovered by future explorers. Furthermore, an advanced Martian civilization might have left behind techno-signatures, not just physical structures but unique chemical or isotopic anomalies in the Martian soil or atmosphere, remnants of their industrial processes or energy consumption. Perhaps the unusual methane plumes detected on Mars, still largely unexplained, are not purely geological but a faint echo of ancient Martian industry or even biogenic activity from a hidden surviving ecosystem. The challenge lies in distinguishing these potential techno-signatures from natural Martian phenomena, a task that requires sophisticated instruments and an open mind. But what could have led to the demise of such a civilization? The loss of Mars' atmosphere and water is a well-documented scientific fact, likely caused by the planet's small size and lack of a strong global magnetic field, leaving it vulnerable to solar winds. This gradual environmental collapse would have presented an existential crisis for any advanced society. Did they succumb to the inevitable, fading into the dust of their dying world, or did they attempt a desperate escape? This leads to the most provocative aspect of our thought experiment, the possibility of panspermia, the theory that life can be transferred between celestial bodies. What if, as Mars became uninhabitable, a desperate Martian civilization launched Ark-like vessels carrying their genetic material, their knowledge, or even their very essence towards a younger, more vibrant world? Imagine a scenario where the seeds of life or even the blueprints of intelligence were deliberately or accidentally transported from a dying Mars to a nascent Earth, effectively kickstarting our own evolutionary journey. This would mean that humanity, and indeed all life on Earth, might be the direct descendants, the inheritors of a lost Martian legacy. Our drive to explore Mars, to seek out its secrets, could be an unconscious echo of a forgotten homecoming, a deep-seated yearning to reconnect with our true cosmic origins. The red planet, then, would not just be a neighbor, but our ancestral home, a silent monument to a civilization that once was, and whose spirit perhaps lived lives on within us. So what if civilizations existed on Mars before Earth? This question transcends mere scientific inquiry. It becomes a profound meditation on identity, legacy, and the cyclical nature of existence in the cosmos. It challenges our anthropocentric view, suggesting that intelligence and civilization are not unique to Earth, nor are they necessarily the culmination of a linear progression. Instead, they might be recurring phenomena, rising and falling across planets and eons, leaving behind only the faintest of echoes for future generations to ponder. The implications are staggering. If Mars once harbored life and even civilization, then the universe is teeming with possibilities far beyond our current grasp. It urges us to look at our own planet and our place in the solar system with a renewed sense of wonder and humility. The red dust of Mars might hold not just the secrets of its own past, but the keys to our own forgotten origins, a cosmic inheritance waiting to be rediscovered. The whispers from the red planet are faint, almost imperceptible, but the question lingers, inviting us to dream beyond the known, to imagine the unimaginable, and to embrace the profound mystery of our shared cosmic journey. Our fascination with Mars is not a recent phenomenon. Ancient civilizations, from the Babylonians to the Egyptians, observed its fiery red glow in the night sky, associating it with war and deities. But it was in the modern era, with the advent of telescopes and space probes, that Mars truly captured our scientific imagination. The tantalizing hints of past water, the polar ice caps, the vast canyons, and the towering volcanoes all painted a picture of a dynamic world, one that might have once harbored life. The question of whether life exists beyond Earth is one of humanity's oldest and most profound inquiries. For centuries, it was relegated to the realm of philosophy and science fiction, but with every new discovery, with every rover that touches down on the Martian surface, that question moves closer to the realm of scientific possibility. The idea of a Martian civilization, however, takes this inquiry a step further, pushing the boundaries of what we consider plausible. It forces us to confront our own biases, our anthropocentric view of intelligence and technological development. Could life and indeed civilization have taken a different path on a different world, under different pressures, leading to outcomes we can barely conceive? This expanded narrative will delve deeper into these possibilities, exploring not just the scientific evidence, but the philosophical and existential implications of such a discovery. We will journey through the geological epochs of Mars, examining the conditions that might have fostered life, the potential forms that life could have taken, and the catastrophic events that ultimately led to its demise. We will also explore the intriguing concept of panspermia, not as a random cosmic accident, but as a deliberate act of survival, a desperate attempt by a dying civilization to seed its legacy across the stars. This is a story that challenges our understanding of history, of evolution, and of our place in the grand cosmic narrative. It's a story that asks us to look beyond the obvious, to listen for the faint echoes of a past that might be our own. Let's delve deeper into the early history of Mars, a period often referred to as the Noachian and Hesperian epochs, spanning from roughly 4.1 to 3.0 billion years ago. During this immense stretch of time, Mars was a dramatically different world. Evidence from orbital missions like Mars Reconnaissance Orbiter and rovers such as Curiosity and Perseverance has painted a vivid picture, a planet crisscrossed by river valleys, dotted with vast lakes, and possibly even harboring a northern ocean comparable in size to Earth's Arctic Ocean. The presence of clay minerals, carbonates, and hydrated sulfates in ancient Martian rocks strongly indicates prolonged interaction with liquid water. Furthermore, the discovery of ancient hydrothermal systems, similar to those found on Earth where life thrives in extreme conditions, suggests prime locations for abiogenesis, the origin of life. Imagine a young Mars, bathed in a thicker atmosphere, perhaps warmed by a greenhouse effect, with volcanic activity providing energy and nutrients. In such an environment, life could have emerged relatively quickly, perhaps even before it gained a firm foothold on Earth. The question then shifts from if life existed to how far did it evolve? On Earth, the journey from single-celled organisms to complex multicellular life took billions of years. However, evolutionary paths are not predetermined. Could a unique set of environmental pressures and opportunities on early Mars have accelerated this process, leading to the emergence of intelligent life forms within its habitable window? Perhaps a form of life that adapted to the gradually changing conditions, developing unique biological or technological solutions to survive the planet's slow desiccation. We might envision a civilization that mastered subterranean living, building vast networks of underground cities and farms, powered by geothermal energy or advanced solar collection systems, long before the surface became the desolate wasteland we see today. Their architecture might have been designed not for aesthetic appeal, but for resilience against cosmic radiation and atmospheric loss, utilizing utilizing the planet's natural caves and lava tubes as foundations for their hidden metropolises. This period of Martian history, rich with potential for life, offers a fertile ground for our speculation, pushing us to consider the myriad ways intelligence might manifest and adapt to planetary change. The search for evidence of a past Martian civilization is not about finding obvious ruins, but rather about deciphering subtle anomalies, much like forensic archaeologists piece together ancient human history from fragmented clues. The lack of plate tectonics on Mars, while preserving its ancient surface, also means that any surface structures would have been subjected to billions of years of erosion from solar wind, micrometeorite impacts, and the abrasive action of dust storms. Yet, this very preservation of ancient terrain offers a unique opportunity. If a civilization built on a grand scale, even if their cities are now reduced to rubble, the underlying geological patterns might still bear their imprint. Consider the possibility of large-scale terraforming efforts. If Martians attempted to reverse their planet's desiccation, they might have engineered vast canal systems, redirected ancient rivers, or even constructed massive atmospheric processes. While the structures themselves might be gone, the altered topography, the unusual mineral deposits, or even the isotopic signatures in the soil could hint at such monumental undertakings. The face on Mars and other anomalies in regions like Cydonia and Utopia Planitia, though often attributed to natural geological processes or optical illusions, continue to intrigue. What if these are not natural but highly eroded remnants of colossal monuments designed to withstand the ravages of time, perhaps even to be seen from space? Their geometric precision, if confirmed, would be a powerful indicator of intelligent design. Beyond surface features, the subsurface of Mars holds even greater promise. As the planet's atmosphere thinned and water retreated underground, any surviving civilization would likely have followed suit. Vast networks of lava tubes, some kilometers wide and hundreds of kilometers long, could have provided natural shelters from radiation and temperature extremes. These subterranean environments could have been expanded and adapted into sprawling underground cities, complete with artificial lighting, hydroponic farms, and advanced life support systems. The detection of such underground complexes would be incredibly challenging, requiring advanced ground-penetrating radar and seismic imaging, but the potential rewards are immense. Furthermore, the concept of techno-signatures extends beyond physical structures. An advanced civilization would inevitably leave a chemical footprint. The processing of metals, the creation of synthetic materials, or even unique waste products could alter the isotopic ratios of elements in the Martian crust or atmosphere. For example, if a Martian civilization utilized nuclear power, we might find unusual concentrations of specific radioactive isotopes in localized areas. If they developed advanced computing, perhaps the remnants of their data storage systems, even if degraded, could leave behind unique molecular patterns. The unexplained methane plumes on Mars are a particularly fascinating techno-signature candidate. While geological processes can produce methane, the variability and localization of these plumes have led some scientists to consider biological or even technological origins. Could these be residual emissions from ancient Martian industrial activity, or perhaps even from a surviving hidden ecosystem powered by advanced technology? The search for these subtle yet profound indicators requires a multidisciplinary approach, combining geology, chemistry, astrobiology, and even archaeoastronomy, pushing the boundaries of our scientific instruments and our imagination. The challenge is immense, but the potential discovery of such techno-signatures would fundamentally rewrite our understanding of life and intelligence in the universe. As we stand on the precipice of a new era of space exploration, with humanity once again setting its sights on Mars, the questions posed by a hypothetical ancient Martian civilization become more pertinent than ever. What if, with every rover that lands, every drill that penetrates the red soil, every telescope that scans the Martian horizon, we are not just exploring an alien world, but slowly, meticulously uncovering our own neighboring cosmic past? The discovery of definitive evidence, a fossilized city, a preserved data archive, or even a clear techno-signature would not merely be a scientific breakthrough, it would be a paradigm shift, a moment that fundamentally alters our understanding of life, intelligence, and our place in the universe. Such a revelation would force us to re-evaluate our history, our philosophies, and our very definition of what it means to be human. It would challenge the notion of Earth as the sole cradle of intelligence, opening up the cosmos to a myriad of possibilities. The implications for our search for extraterrestrial life would be immense, transforming the quiet hope of finding microbial life into a vibrant expectation of encountering other advanced civilizations, past or present. It would infuse our space endeavors with a profound sense of purpose, us, turning the exploration of Mars into a pilgrimage, a journey to reconnect with our ancestral roots. Moreover, the lessons learned from a lost Martian civilization could be invaluable for our own future. Their struggle against environmental collapse, their technological ingenuity in the face of adversity, and their potential decision to seed another world would offer a rich tapestry of experiences from which we could draw wisdom. It would serve as a powerful reminder of the interconnectedness of life and the fragility of planetary ecosystems, urging us to be better stewards of our own planet and to approach interstellar expansion with humility and foresight. The Martian story, however speculative, becomes a guiding light, illuminating the path forward for humanity as we venture further into the cosmos. The red dust of Mars, therefore, holds more than just geological secrets. It holds the potential for a cosmic truth that could unite humanity under a shared ancient heritage. The whispers from the red planet are faint, almost imperceptible, but the question lingers, inviting us to dream beyond the known, to imagine the unimaginable, and to embrace the profound mystery of our shared cosmic journey. The possibility of a Martian civilization before Earth is not just a tale of what might have been. It is a powerful narrative of what could be, a testament to the enduring spirit of life, and a call to continue our relentless quest for knowledge, for understanding, and for our place among the stars.